To understand a new AI concept, you usually start in one of two places: a 20-page research paper filled with dense equations, or a 500-word blog post that skips the actual engineering. This creates a constant trade-off. You either spend hours decrypting academic jargon just to find the main idea, or you settle for a summary that lacks the technical detail needed to actually build something. Google's NotebookLM provides a middle ground. It is a research workspace that uses your specific files as its only source of truth. This prevents the AI from hallucinating, which is when a model confidently invents facts that aren't there. To set this up, you need a Google account, a PDF of the original research paper, and the URL for a high-quality explainer blog. By combining these two sources, you create a system that can translate scientific definitions into logical, step-by-step explanations without losing the technical accuracy of the paper. Inside the NotebookLM interface, locate the Sources panel on the left side of your screen. Upload your primary technical source first. This is usually the original PDF of the AI research paper. Then, paste the URL of your explainer blog directly into the same column. This creates a grounded knowledge base. The AI is now strictly prohibited from using its general training data. It can only answer questions using the facts found in these two specific documents. If you only upload the academic paper, the AI's responses will often be as dry and difficult to read as the paper itself. The blog post provides the accessible language, while the paper provides the scientific evidence. Together, they allow the AI to explain complex topics with both clarity and rigor. With your sources locked in, move to the central chat interface to begin extracting the technical details. Use the mechanism prompt. Type, "Summarize the paper in 10 sentences, but focus on the architecture, not the benchmark results." Benchmarks are the standardized tests used to measure a model's performance, but right now, we want to know how the system actually works. The AI will now cross-reference the paper's technical definitions with the blog's analogies to explain the underlying logic. Every sentence in the response includes a small citation number. Clicking these will highlight the exact paragraph in your source documents, so you can verify the information yourself. Next, use the whiteboard prompt. Ask the AI to describe the concept as a step-by-step system design pipeline. This forces the model to organize abstract theory into a chronological sequence. This specific instruction stops the AI from giving a general summary. It has to explain how data actually flows through the system from start to finish. These constrained prompts turn the AI into a specialized tutor that focuses only on the specific mechanics you need to understand. To move from theory to practical engineering, use the real-world constraints prompt. Ask the AI for the system's engineering constraints, such as indexing costs and latency. Latency is the delay or time it takes for a system to process a request. Understanding where a system fails or hits a limit is what builds technical intuition. It allows you to see the practical trade-offs an engineer has to make. Chat data is temporary. If you close your browser or start a new session, these specific insights are difficult to retrieve. To save your work, navigate to the Studio button at the top of the interface. Once inside the Studio, click a Report button. The AI now takes your entire chat history and both source documents and weaves them into a single structured file. This single click generates a permanent briefing document that you can use as a technical reference for your project. Your finished briefing document appears in the main window, containing all the architecture notes and system design steps you generated. The text provides a balance of high-level intuition and low-level technical accuracy, all grounded in your original sources. As you continue your research, you can add new sources to this same notebook, like YouTube transcripts or documentation pages. This process replaces scattered browser bookmarks with a centralized knowledge base that grows more detailed the more you use it. Instead of searching through a chaotic history of links and tabs, you now have an organized library of technical insights, ready whenever you need to revisit a complex topic.